This first video is on the basics of differentiation. Now, differentiation is something you don't encounter at all at GCSE, so this might be something completely new to you. Okay, so here we have a straight line and it has the equation y is equal to mx plus c. We talked about in chapter 5 other ways we can give the equation of a straight line, but this is one of them. And this is where m in this equation is equal to the gradient. Now, the actual definition of the gradient is how much y goes up by when x goes up by 1. And the key thing with a straight line is that the gradient is constant. It's just a number. It's like 1, 2, 3, something like that. So for example, let's just say that the gradient or the equation of this line is y is equal to, I don't know, 6x plus 4. That means the gradient is equal to 6, and that means when x goes up by 1, y goes up by 6. But the key thing to take away from this is that the straight line has a constant gradient, and this makes sense if you think about it, because no matter where you are on the line, so for this specific equation, if you go up 1 by x, you're going to go up 6 by y. Another way to think about the gradient is the slope, and hopefully you can see for the for a straight line, the slope is the same throughout the whole line. So now let's consider a curve. So here is pretty much the most basic curve you can get. Y is equal to x squared. Now here, hopefully you can see that the gradient is no longer constant. The gradient is a certain value here, but then it's a different value here and a different value here, and so on and so forth. And this is because the graph bends and it's no longer a straight line. Now, the best way to illustrate this is with a tangent, and this is quite a key concept for the whole of this chapter. A tangent is a line that touches the curve at only one specific point on the graph. So for example, this here is a tangent as it touches the curve only at this specific point here. This is also a tangent, it touches the curve just at this one specific point here. Now really quick, for more complex graphs like quartics, where you could get something like this, you could have a tangent here where it only touches the curve at this particular point, but it also intersects the curves at these other 2 points here. That's fine, this is still considered a tangent. The kind of the main feature of a tangent is it only touches the curve once, kind of in this general vicinity. If it intersects it at other points, this doesn't really matter. That's not really the point of focus. Now, the key feature of a tangent is that the gradient of a tangent is equal to the gradient of the curve at the point it touches. So for example, let's say we have a tangent that touches the curve here, and let's say this is where x is equal to 4, and let's say that the gradient of this tangent, which is a straight line, is equal to 8, then this means that at this specific point where x is equal to 4, the gradient of the curve is equal to 8. And you can very easily see by using tangents that the gradient of the curve is always changing, because let's say we draw a tangent up here where it touches the curve here, you can see that these two tangents now have different gradients. So the gradient is always changing throughout the curve. So the gradient for a curve is not constant like a straight line. So what we need is an expression or a function for the gradient of a curve, where the gradient changes for where on the curve we're talking about. So let's say that we have the curve y is equal to x to the power of n, where n is a number, so 1, 2, 3, 4, something like that. We can make something called a derivative. It's also sometimes called a gradient function. And what this is a function that tells us what the gradient is for each value of x on the curve. And we call this dy over dx. So if y is equal to x to the power of n, dy over dx is equal to nx to the power of n minus 1. This is a really important rule that you need to remember. Now, sometimes it might be written instead as a function of f of x is equal to x to the power of n. This is the exact same thing, it's just got a slightly different notation when you do the derivative. Instead, we call it f dash of x is equal to the exact same thing, n of x to the n minus 1. These are the exact same thing, there's no difference between them, it's just got a slightly different way of writing it, so recognize them both. So, for example, let's say that y is equal to x to the power of 3. So what is dy over dx going to be? Well, in this example, 3 is what n is, so therefore it's going to be, if we use this formula here, 3x the power of n minus 1, so it's going to be 3 minus 1, so it's going to be to the power of 2. Let's do another example. Let's say that f of x is equal to x squared. So the derivative f dash of x is going to be equal to 2x to the power of, so 2 is n, so it's going to be 2 minus 1, so it's going to be to the power of 1. But obviously we don't really need to write to the power of 1, we can just leave it like that. So what does this actually mean and do? Well, what it does is it allows us to find the gradient at a specific point. So for example, let's say that we wanted to find the gradient at x is equal to 3. Well, what we can do is just plug 3 into this formula to do f dash, and we plug in 3 in for x, is equal to 2 times 3, which is equal to 6. So therefore, this tells us that the gradient when x is equal to 3 is equal to 6. And this is really useful because it can tell us the gradient of any value of x. The gradient when x is equal to 4, just plug it into this formula here, is equal to 8. The gradient when x is equal to 5 is equal to 10. So let's do some more examples. So y is equal to x to the power of 4. So therefore dy over dx is equal to, so 4 is equal to n, so just plug it into this formula to get that dy over dx is equal to 4x to the power of 3. Do another example, f of x is equal to x. Now remember, this is actually x to the power of 1, but we don't really write the 1. So therefore f dash of x is equal to, so this is the 1 here, so it's going to be 1 x to the power of 0. Now, when the coefficient is 1, we don't really need to write this. Now, x to the power of 0, remember, anything to the power of 0 is just equal to 1. So therefore, f dash of x is just equal to 1. Let's do another example. Let's say that y is equal to x to the power of a half. Therefore, dy over dx is equal to, so half is equal to n. So it's going to be equal to half x to the power of minus a half, as a half minus 1 is equal to minus a half. And for the final example, f of x is equal to x to the power of minus 2, so therefore f dash of x is equal to minus 2x to the power of minus 2 minus 1 is equal to minus 3. So just a quick reminder of what this means. So it means we can find the gradient at any point. So let's say for this final example, we wanted to find the gradient when x is equal to 1. We just plug x into here to get f dash of 1 is equal to minus 2, 1 to the power of minus 3, which if you put this into a calculator, is equal to minus 2. So therefore, when x is equal to 1 for this graph, the gradient is equal to minus 2. And again, I just want to remind you, please don't get confused about the y and the f of x and the dy over dx and f dash of x. These are literally the exact same thing, it's just two different ways of writing it that you could meet. If there's already a coefficient at the front of the term, you just times whatever coefficient is created by the differentiation by that original coefficient. So for example, let's say that y is equal to a x to the power of n, where we have a coefficient in front of x, then that means that dy over dx is just going to be a times, and then this differentiated, so n x to the power of n minus 1, and of course if it's f of x, then f dash of x is equal to a times nx to the power of n minus 1. You just times whatever the coefficient is by the differentiated term. So for example, let's say that y is equal to 3x to the power of 4, then that means that dy over dx is equal to 3 times, and then the differential of x to the power of 4. So that is going to be 4x to the power of 3, and then you just simplify that to 12x to the power of 3. So here's a couple more examples. So y is equal to 2x to the power of 3 over 2. Therefore dy over dx is going to be equal to, so it's the original coefficient 2 times, and then just do the differentiation, 3 over 2x to the power of a half. And if you just simplify that, these two are going to cancel out. So therefore it's going to be 3x to the power of a half. Let's do another example. So f of x is equal to minus x to the power of minus 3. Therefore it's going to be f dash of x is equal to minus 1, because remember this is actually minus 1, the coefficient, minus 1 times, and then do the differentiation, minus 3x to the power of minus 4. And if you simplify that, minus 1 times minus 3 is just going to be equal to 3. So it's 3x to the power of minus 4. The last example, y is equal to 6. Remember, this is technically 6x to the power of 0, as this is 1. So if you differentiate this, dy over dx, this is going to be equal to 6 times, and the differentiation is going to be 0x to the power of minus 1. We're doing 6 times 0, so therefore this whole thing is just going to be 0. This is something that you just need to remember, is when you differentiate a constant, it always becomes 0. That's just something you need to remember. If you have more than one term in an expression, this is very easy. You just differentiate each term individually. So here we have y is equal to x to the power of 4 plus 2x to the power of 3 minus x squared. So we just differentiate them individually. So let's start with x to the power of 4. That's just going to be 4x to the power of 3. 2x to the power of 3 is going to be 2 times, and differentiate x to the power of 3 to get 3x to the power of 2, and simplify that. 2 times 3 is 6x squared, and then minus x squared is just going to be minus 2x, and then to the power of 1, but we don't write that. So therefore the whole thing, dy over dx, is just these terms added together. 4x cubed plus 6x squared minus 2x. So just differentiate the terms individually. Here's another example. Again, just differentiate the terms individually. So x squared is going to be 2x minus 2x is going to be minus 2. That's a bit of a tip when it's x to the power of 1, is that whenever you differentiate it, just the x goes away and it leaves you with a coefficient, so it's just minus 2. And then the constant at the end, remember when you differentiate a constant, it just goes away. So therefore, the whole thing, dy over dx is equal to 2x minus 2. So one final example. Now here we have the 1 over x, and at first you might not know how to differentiate this, but remember the indices law, that 1 over x is equal to x to the power of minus 1. So therefore we can rewrite this as y is equal to x to the power of 3 plus 3 over 2x squared minus x to the power of minus 1. And therefore we just differentiate these terms individually. X to the power of 3 is 3x squared. 3 over 2x squared is going to be 3 over 2 times, and then x squared is going to be 2x, and we can simplify this by these two denominators cancelling out, or this denominator cancelling out, sorry, to give 3x, and then this one here, so we've got a minus 1 coefficient here, so it's going to be minus 1 times, and x to the minus 1 differentiated is minus 1x to the power of minus 2. Simplify this, minus 1 times minus 1 is just equal to 1. And remember, when it's coefficient, we don't really write the 1. So therefore, it's just going to be x to the minus 2. Be careful with this, because there's so many kind of like minuses going involved. So it might be like easy to make a mistake, so just be careful. So therefore, dy over dx is equal to all these terms added together, 3x squared plus 3x plus x to the minus 2. So a lot of the time they will give you kind of more complex examples that first you will need to simplify to get it to an easy polynomial that you can differentiate. So these two, I've only shown one on the screen now, I'll go through the other one in a sec. These two examples are actually I've taken directly from the spec. So for this one, what you're going to do is first of all you just have to expand the brackets. So y is equal to 2x times x is equal to 2x squared, and then 5 times x is plus 5x, minus 1 times 2x is minus 2x, and then 5 minus 1 is going to be minus 5, and you can simplify this to 2x squared plus 3x minus 5, and therefore dy over dx is equal to, we differentiate these terms individually, so 2x squared is going to be 2 times an x squared is 2x, it's going to be equal to 4x, and then this is just going to be 3, and therefore the minus 5 disappears. So therefore it's going to be 4x plus 3, and that's the final answer. So for this example, again, we need to simplify first, and we've got all these terms in the numerator and only one term in the denominator, so therefore we can divide each of these terms individually by the denominator on the bottom. If you want to, an easier way to write this, to show this, we can write this as x squared over 4x to the half plus 3x over 4x to the half minus 5 over 4x to the half. And then we can simplify this. So this is actually a 1, so therefore it's going to be 1 over 4. Remember how the index law works is when you have a power divided by a power, the two powers minus. So this is going to be x of 2 minus a half, which is going to be equal to x to the power of 3 over 2. So 1 over 4 x to the power of 3 over 2. For the second part, it's going to be 3 over 4. Remember, this is actually a 1, so it's going to be 1 minus a half, so it's going to be x to the power of a half, and then it's going to be minus 5 over 4. Remember, this is actually an x to the power of 0 technically, so it's going to be 0 minus a half, so it's going to be x to the minus a half. And then we can differentiate this from here, the individual terms. So let's start with this one. This is going to be 1 over 4 times, and then we differentiate the x to the power of 3 over 2 to get 3 over 2 x to the power of a half, which if we simplify this, it's going to be 3 over 8 x to the power of a half. The next term is going to be 3 over 4 times, and then we differentiate x to the power of a half to get half of x to the power of minus a half, which is equal to 3 over 8 again, x to the power of minus a half, and then for the last term is going to be minus 5 over 4 times, and it's going to be minus a half x to the minus 3 over 2, and this is going to be equal to, we've got two minuses, so these cancel out, so therefore it's going to become 5 over 8 x to the power of minus 3 over 2. So the overall differential f dash x is equal to 3 over 8 x to the half plus 3 over 8 x to the minus a half plus 5 over 8 x to the minus 3 over 2, and that's the final answer. So really quick, I just want to go something really, really powerful that your calculator can do, and it can help you check whether you've got the right answer. So on your calculator, I've circled that there's a little thing here that says d over dx, and then it's got a square, and it's in yellow. So if you press shift and then you press this button, it will give you this thing here where it says d over dx, and then it's got this blank bracket, and then next to it it's got this x is equal to something. And this is a really, really powerful thing that your calculator can do, because what it can do is for any function, if you put that function into that bracket and then put in any value for x, it will figure out the derivative for that value of x. So for example, so see that little x button next to this button, if you press that, that allows you to put x into your function. So using that, I can put the function that we figured out here for the last question that we just did, and I've put it into the bracket here, and I'm just going to put in any value of x. It doesn't really matter what, I'm just going to put in 5. So if I put in 5, it gives out a value, the calculator, of 1.062, and then the rest of the numbers don't really matter. So what the calculator is saying is that derivative, when you differentiate it and then put in that value, it will give out this value for the gradient at that point. So why is this useful? Because that's what the calculator gives out. So now we can check for the value that the derivative that we've got, whether we've got the right answer by subbing in the same number. So we subbed in 5 using the calculator. So if we just sub in 5 for this here, and this is equal to 3 over 8 to the 5½ plus 3 over 8 to the 5 over minus a half plus 5 over 8 to the 5 of minus 3 over 2. This should also give out 1.062 if we've got our answer correct, because the calculator is giving us the correct answer. We need to check if we've done it correctly using this, and if you put this into a calculator, it does give out the value of 1.062, etc, etc. So this is a really good way to check if you've got your answer right, because the calculator can differentiate for you in order to do it. Now, one thing I do have to stress is that you cannot just do this to get the answer. If you're given this question here, you can't just put this into a calculator and give out this value, because obviously the examiners are aware of this, and therefore you know that you haven't actually done any maths. You just plugged it into your calculator. So you have to show your working, and you have to come to this yourself. But what this is useful for is checking your answer, because you can check that the value that you give out for your derivative at a random point is the same value that your calculator is given out for the derivative at the same point. So here's a couple of questions on differentiation basics. So pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for question 1, let's rewrite this with the indices. So this here, we need to write it as, so let's write the whole thing, y is equal to 3x squared plus 6x to the power of 1 over 3, and then plus 2x cubed minus 7 over 3x to the half. And then we can divide both of the terms in the numerator by the denominator. I'll write out the whole fraction in order to make it a bit more clear. So 3x squared plus 6x to the power of 1 over 3 plus 2x cubed over 3x to the half minus 7 over 3x to the half. And then we can simplify this by doing y is equal to 3x squared plus 6x to the power of 1 over 3 plus, and it's going to be 2 over 3. And remember, when you divide powers, you minus them, so it's going to be 3 minus a half. So this is going to be 2 over 3 x to the power of 5 over 2, and then minus 7 over 3. Remember, this is actually x to the power of 0, so it's going to be 0 minus a half, so it's x to the power of minus a half. And then from here we can differentiate this by just differentiating all the terms individually. Okay, so 3x squared over here is going to be 3 times, and then the differential of x squared is 2x. I'm going to simplify this to 6x. 6x to the power of 1 over 3 is going to be 6 times, and the differential of x to the power of 1 over 3 is 1 over 3 x to the power of minus 2 over 3, which is equal to 2 x to the power of minus 2 over 3, and then 2 over 3 to the 5 over 2 is going to be 2 over 3 times 5 over 2x to the power of 3 over 2, which you can simplify by cancelling these two out to get 5 over 3 x to the power of 3 over 2. And then for the minus 7 over 3, it's going to be minus 7 over 3, and then it's going to be the differential of x to the minus a half, so it's going to be times half, or minus a half, x to the power of minus 3 over 2, which we can simplify. 2 minuses cancel out, so it's going to be 7 over 6 x to the power of minus 3 over 2. So we can rewrite the whole thing as a differential by adding all of these terms together. So dy over dx is going to be equal to 6x plus 2x to the power of minus 2 over 3 plus 5 over 3, x to the power of 3 over 2 plus 7 over 6, x to the power of minus 3 over 2. And we can check this answer, as we said before, by doing it into our calculator. So if we put this here into our calculator, in the brackets of the d over dx, and I'm going to, you can't see it on the calculator here, but I'm going to make x equal to 5, it gives out a value of 49.42, and then a bunch of numbers, it doesn't really matter, and therefore we can then put x is equal to 5, the same number as the value, into our expression that we've got, and this will give out 6, 5 plus 2, 5 to the power of minus 2 over 3, plus 5 over 3, 5 to the power of 3 over 2 plus 7 over 6, 5 to the power of minus 3 over 2. And if you put that into a calculator, it also gives out the value of 49.42 and then a bunch of decimals. So as these two values are the same, this is a really good way of checking that we have got the right answer. Okay, so for part A, the first thing we need to do is expand the brackets. So 1 minus 2x squared is equal to 1 minus 2x times 1 minus 2 x, and if we expand the brackets, we're going to get 1 times 1 is 1, minus 2x times 1 is minus 2x, and obviously that happens twice, it's going to be minus 4x, and then minus 2x times minus 2x is plus 4x squared. And now we can just differentiate this. It doesn't actually give us y or x or f of x, sorry, so we're just going to say that it's equal to y, so therefore dy over dx is going to be equal to, and we differentiate each of the terms individually. The 1 is a constant, so it goes away. Remember the thing with when it's like minus 4x, it just becomes minus 4, the x just goes away. And then 4x squared is going to be 4 times then x squared is 2x, which is equal to 8x. So therefore, the overall term is minus 4 plus 8x. And again, a way to check is if you put into your calculator the differential of 1 minus 2x squared, and then you put in a random value, I put 5, you get out a value of 36, and if you sub in 5 for the value of x here, it actually gives you out a value of 36 as well. So therefore you can check that you've got the right answer. So for part B, first of all, let's write this where we've got the root x as x to the power of a half, so it's going to be x to the 5 plus 6x to the half over 2x squared, and therefore we can split the fraction to do it like x to the power of 5 over 2x squared plus 6x to the half over 2x squared. Therefore we can simplify this by, remember there's actually a 1 here, so it's going to be a half, and then it's going to be 5 minus 2 as it's a power, so it's going to be x to the power of 3, and then plus 6 over 2 is 3, and it's going to be x, and then it's a half minus 2, which is equal to minus 3 over 2. So that's what y is, so therefore dy over dx is going to be equal to, and then we differentiate the terms individually, so it's going to be a half times the differential of x to the power of 3, so it's going to be 3x squared, which is equal to 3 over 2x squared. Then this part is going to be 3 times, and it's going to be minus 3 over 2 x to the power of minus 5 over 2, which simplifying that is going to be minus 9 over 2 x to the power of minus 5 over 2. So therefore dy over dx is equal to 3 over 2 x squared minus 9 over 2 x to the power of minus 5 over 2. And again, you could check this really powerfully and really usefully using your calculator by putting in the expression here into the brackets of d over dx, and then I use x is equal to 5, and that gave out a value of 37.4195, and then low numbers. And then if you use the x is equal to 5 into here and you sub these value in, it gives out 37.4195 as well. So that's a good way to check your answers.